Alright, what's up guys? Welcome to question 2. My name is Gaston Mapala. Now let's have a look at this question here, which is from June exam 2025 paper 2. It is a statistics question. If you haven't watched question 1, please check on the description below. You will see question 1 where you can start this. It's basically the whole paper, which is paper 2 for this year's June exam, which is the year 2025. Right now, let's have a look at this question. Let's go through it. The manager of a supermarket decide to do a survey on the number of items that the customer orders online and the time in minutes that the packer took to have the order ready. So basically, this is some of the things that checkers and then Mr. D and all these supermarkets, they try to check how long does it take for you to have your order packed and delivered to you. So in this case, they're just monitoring how long does it take a packer take for each and specific order. So the supermarkets received online orders on a certain day. The information for these 10 orders is shown in the table below. So we've got here on the x-axis, we've got number of items and also the time it took. So as you can see here, for 10 items took 5 minutes, 3 items took 5 minutes, for 20 items it took 9 minutes. So now this is x-axis and this is y-axis. All right, so let's have a look at 2.1. 2.1 says draw a scatter plot on the grid provided in the answer sheet. So in this case, you would have an answer sheet that has got a grid on it. So they're saying we need to draw and represent this in the form of a scatter plot. So for me here, guys, I'm just gonna show you, but I'm not gonna use the answer grid. I'm just going to show you a little bit of a scatter plot here so that you can have some sort of a representation of this data here. So I'm just gonna do 2, 4, 6, 8, 10, all right, 12, 14, 16, right? And then similarly on the y-axis, I will do the same thing, 2, 4, 6, 8, 10, 12 as well. Okay, then we're gonna have 14. 14 here. Then we're also going to have 16, right? So therefore, then it's gonna be y-axis, then it's going to be x-axis there, right? So now it's time to do the scatter plot for this data. I'm just gonna indicate that with red. So for every 10 items, which is on the x-axis, so this one here will be number of items. This is number of items, and then here you have got the time it took to pack the items. The time here it's given in minutes, right? So this is going to be minutes, right? So now if you look at this one, guys, for every 10 minutes, how many items are packed? You've got 5 items. For every 10 minutes, you've got 5 items somewhere there. And then for every 3 items, what do you have? You've got 5 minutes somewhere there. And then as you can see, guys, but basically this is what you would do on the grade for you. It's going to be quick and easy, right? So 20 items will be somewhere here, so I'll have to extend this to 18, and then 20 items. For 20 items it took 9 minutes, so somewhere here we have got 20 items, 9 minutes. And then for 14 items, how long did it took? It took 7 minutes. 7 minutes, or 7 is a bit lower. 7. I hope you can see what I'm doing, guys. 7 minutes somewhere there. And then for 17 items somewhere here in the middle, it took 6 minutes exactly. Okay. And then for 9 items somewhere here, it took us 6 minutes. 12 items, 8 minutes. Okay, and then for 15 items, somewhere here, it took us 10 minutes, somewhere there. And then for 12 items, it took us 19 minutes. Ooh, 19 minutes is somewhere up there. Right, it's fine. Hey, no. I'm confusing the two now. For 19 items, it took 12 minutes, not the other way around. Okay, excuse me for that. You see, guys, it's easy to swap X and Y. So now they just said we must just draw a scatter plot, and then okay, that's it. That's your scatter plot here. And then excuse me, guys, I dropped my mic. All right, now it says here, we need to 2.2 says determine the equation of the least square regression line. So in this case, guys, you're going to use a calculator where you have entered the data in your calculator. So you would know that this is the general equation that we use to determine the line of regression. So you must look for A in our data and look for B in order for us to have. It's going to be a line that will be somewhere here, guys, which is a straight line. For that matter, it's a line of best fit. So that line will be somewhere here, just to illustrate that. Okay, so now let's go ahead and look at our calculator and see what it's the data holding for us. All right, there's our calculator there. Right, so now with our calculator here, it says here, okay, I've already entered the data, guys, but basically what you would do, you would come here and say setup mode, then you go to statistics, which is number 3, and then you choose this one here, which has got A and B as the same as the general equation. You would choose 2, and then you would enter your data here in this case. Right, okay, guys, I already have my data added in. So this is what you're gonna do. You're gonna come here and say shift statistics, then you go to choose number 5, which is regression, then you choose 1, then you press equal sign. Now that you have got the data, so we know that the value of A is 3.08 in this case. So the value of A will be 3.0, right? And then the value of B, come here, shift 1, then you choose here on regression the value of B, which is at 2. You're gonna choose 2, then you set equal sign. The value of B is 0.35. Okay, 0.35. That will be our answer. So let's go. So this is our values here. The value of A is going to be, as calculated previously, 3.08 is our value, and then B is 0.35. So therefore our equation would therefore be Y it's equals to 3.08 and then plus B, which is 0.35x. Okay, so that's our equation right there. So now let's move on to 2.3. 2.6 said write down the correlation coefficient. Correlation coefficient shows you how best is the data fitting in this case. So correlation coefficient refers to the value of R. So now let's go ahead and look for this value of R here. All right, okay, now come here into our equation and you say shift and then start, then you go to regression, then you look for the value of R. You see there R is number 3, so you're gonna say value of R, which is 3, then you say equal to, so the line is 0.74. so that's our R. So let's go ahead and put, so our R value in this case is 0.74. right? So let's go 2.4. guys, I hope you're following. If you're not following, please let me know on the comment section below, and then we'll see what we can do. So it says here the supermarket received an online order for 13 items. So now in this case number of items is at X, so it means here they're giving you the X value. Predict how long in minutes will it take for the packer to pack the order and have it ready for delivery. So now this is 2.4. Okay, so now it means on our equation, the one we just found now, they are telling us that the X value in this case is 13. So what will be the Y? Right, so X is equals to 13. So what will be the Y? So Y is equals to 3. Sorry, excuse me. 3.08 plus 0.35, and therefore 13. So therefore our Y value will be equal to, checking on my calculator, 7.63 minutes. That's how long it will take for the person to pack, the packer to pack the orders, 13 orders. Right, so now it says here 2.5, explain why the y-intercept of the least square regression does not make sense in this context. Okay, so now they're asking us why we don't have a y-intercept. So let's just go and check. Y-intercept is what? Is minutes. So there is no way that you can have a person packing the orders and then they use 0 minutes. So that's why it wouldn't make sense for it to be 0. You're always going to take time to do something. So you can't say the packer took 0 minutes. That packer would have to be very fast, or maybe from Limpopo. I don't know. Sorry guys, I'm also from Limpopo, by the way. So yeah, but I'm just trying to make it possible for you to understand that there's no way that a person can use 0 minutes to pack orders. They have to use some sort of either they can use 60 seconds or 50 seconds if it's one order, but there's no way they can use 0 minutes. So and also the items ordered cannot be 0. You see, so you can't have 0. If you have got 0 orders, it means you've got also nothing to pack. So simply you can say because it cannot be 0. Okay, so it can't be 0. So that is your reason there. It can't be 0. Because you will never have what? 0 items ordered, ne? Because you will never have 0 items ordered. Okay, so and then that's how you would answer this one based on the context of the question. I am Gaston Mapale. Let me see you on the next one, where we'll be doing question 3, which is on analytical geometry. It's an interesting one, guys. Make sure that you stay tuned and view the next video. See you on the next one.